the Raptor demonstration. You go to any air show and you want the Raptor demo, is amazing. It is a truly, it defies physics seemingly, turns into a helicopter, turns into a UFO.
Hey everybody, and welcome back to the Kodiak Shack podcast. Today we have Scar, who flew the Raptor, and now he's at Blue Force Technologies. But before we get to that, because I always forget the admin, so I want to do it now. If anybody knows or has ever sat in a brief of mine, they know my admin is trash. So we'll get it out of the way. But thank you everybody who listens to the show. I really do appreciate it. Things that we would like, if we can, request these things. 5-star review. Apparently that's an important thing on podcasts. I never ask for it, but if you are interested and you think we deserve it, or even if you don't, please give us a 5-star rating for the Kodiak Shack podcast. And then we also appreciate the fact that some of our listeners have actually been providing some feedback, not only to our email, but on YouTube and different platforms. So please send in your questions, comments, concerns, because we are actually going to talk about some of the topics that our listeners have brought up in the past. So thank you for those listeners who have brought that up. So admin out of the way, I probably forgot some stuff. We're work in progress. But Scar, well, before I let him talk, he's an Academy grad. He knows my boy Tron that we talk about a lot on the podcast. That's Lewis Bloom. And he flew the Raptor, and then he ended up working at Blue Force. So we'll talk about his transition there, some of the Raptor stuff. So Scar, thank you for being here, and tell us about yourself. It's not a trap.
Yeah. Yeah, thanks, Vader. Yeah, Andrew Van Timmeren, go by Scar. We're recording this from the great state of Michigan, where I've got 1.5 feet of snow, fresh powder out in my backyard, which is awesome. Grew up here, like you said, went to the academy, was fortunate enough, blessed with Raptors straight out of pilot training, flew those for my entire career. We could get into my transition story, out of the military as desired, but ended up leaving the military right as COVID hit in the summer 2020, which was hair raising and freaked me out, quite a bit, but, we got through it. Landed with a pretty awesome job first out of the gate, working for the Advanced Battle Management System program, then moved over to the Rapid Capabilities Office, all the while I was, permanently DNIF going through my medical stuff, was sitting on staff, moonlighting a little bit at ACC, Air Combat Command at Langley Air Force Base, which, for those of you who don't know, is the major command, the major organization within the Air Force that governs the combat air forces, so fighters, personnel rescue, handful of other cats and dogs, cyber, got into a meeting where I was with this little company called Blue Force Technologies that had this crazy idea about an unmanned fighter. And once innovation or like cool products, things that make a difference, you can't unsee it once you see it. And so I kept in touch with those guys throughout, my entire, story. And then when the opportunity presented itself to jump on full time with them, I couldn't not. And so I've been working with Blue Force for full time for actually just over a year now, just crossed the year mark. My title is the Vice President of the Air Dominance Division. What that means, that makes two of us because I also don't know, but we're trying to do good things for America, helping out the bros, and that's the motivation I have that gets me up every morning, truly, because I miss the fellas, I miss the team. It's amazing, what combat aviation and that camaraderie, the family, it's awesome. So anything that, we can do to support that, truly, that's not, BS, mean it. And so that's what we're up to.
Nice. And I'm a C model guy now, so I like air dominance too. So I dig.
Yeah, there you go. Yeah, that's right.
So, well, it's great. So I think we have a great opportunity to kind of dig into some topics that we've kind of been asked about by some of our listeners. So obviously I flew the F-16, and now I'm currently flying the F-15C, which the C and the E, the F-15C model and the Strike Eagle, the E model, do have differences in their flight controls. And then the Raptor is almost like the best of both worlds. So we'll kind of get into that. Scar, I'll let you talk. I am mildly smart on the F-16, woefully unprepared to talk about the C model. So hopefully you can bring it all home. But those who are not insane aviation enthusiasts, the F-16 is referred to as a fly-by-wire jet. So what that means is there are no controls like any normal general aviation, think like a Cessna, that actually connect the inputs you make to the actual control surfaces. So you'll have things like ailerons and flaps, and you'll have your elevators and your rudder, which is normally how most airplanes fly. Most fighters don't use elevators. They have their horizontal stabilizer is kind of embedded and fully mobile to create the most nose rate or nose track or just maneuverability of the aircraft. So the F-16, the C model, and the Raptor all share that same thing. The difference about the F-16 is it has leading edge flaps and trailing edge flaps to change the shape of the wing. Depending if you're really fast, those flaps come up. If you're really slow, those flaps come out. So your wing kind of gains I believe it's camber, through those flight envelopes, where the C model is a solid wing. So what that means, it has ailerons and flaps, but it doesn't really use the flaps in flight other than for takeoff. And the wing doesn't change shape, unlike the F-16. So these are kind of the two differences. And the C model, it actually, if I pull back on the control stick, it actually, using hydraulic assistance, will move the control surfaces. So the big difference is if I pull back in the F-16, and this is similar in my understanding to the Raptor, the jet, or there's a computer that says, hey, he wants this, and then it will use whatever control surface it deems necessary to get that nose track. So people, so Scar, some background here is people are like, hey, it seems like you're not overly excited about the C model. And it's not that I'm not excited about the C model. It's that the F-16 uses a computer to save you from yourself, not specifically from over-G'ing the jet or over-G'ing yourself, which both are possible in the F-16. But when you pull back, the jet will say, hey, I'm going to use instead of just ailerons or just stabs or just flaps or just rudder, it's going to use whatever the computer deems necessary to get you the performance. And if there's any sort of like adverse yaw or any sort of aircraft specific, I guess, deviation or problem, the jet will overcome that on its own. So now jump into the C model. The C model does not stop you. If you pull back to the CPAN 1, you could literally rip the wings off the aircraft, and sadly it's happened in the past. But in addition to that, you can over-G it, and then you can also ask too much, where now you break science here that I'm not prepared to talk about, laminar flow over the wing, which means effectively creating that lift. So if you ask too much in the C model, the jet's not going to stop you. It's just going to stop flying, and you're effectively what's called in the heavy wing rock, and it kind of flops around, and it's not really turning, it's not really flying, it's just kind of like falling in the sky. So those are the things that make it difficult, because the jet doesn't help me in the C model. So those are the difference between the two. That's why BFM and the C model is very different than the F-16 and not what I'm used to. So now I've explained the C model, which is like a more traditional or like a legacy type flight control system, and the F-16, which is kind of the basis for what everything else was built on. So Scar, go ahead and hit him with how the Raptor is the same and different. We here at the Kodiak Shack podcast would like to welcome our new sponsor, Adamus Cyber. Working with the military means there are some minimum cybersecurity requirements that are in every contract. Complying with these requirements can be painfully slow and really take your company's focus off your military customers and end users. Thankfully, the team at Adamus has simplified the process exclusively for small businesses working with the military. It should be expected that security requirements are going to be a part of working with the military, but they don't have to be difficult. Learn why prior guests on the podcast like Arun from Ops Lab or Brian from ResCon use Adamus to comply with the NIST 800-171, DFARS 7012, and CMMC cybersecurity requirements in their contracts. Check out their website at www.adamuscyber.com and tell them you heard about them from the Kodiak Shack podcast. Their website will be in the show notes. We appreciate all the companies that want to work with the military, and we understand working with the government isn't always the easiest thing, but we appreciate companies like Adamus that make it just a little bit easier.
No, it is much more aligned with the F-16 than it is the C model or E model Eagle. And so let's talk about some cockpit ergonomics first. So in the Viper, just as the same as the Raptor, same as the F-35, different from the Eagle is the stick is on the side. That is versus the Eagle, you got the center stick. I believe the Hornet, Super Hornet are center stick. As we move up into 5th gen, and beyond aircraft, I think side stick is probably going to end up being the norm. And the reason is because it is a digital fly-by-wire system. So we have 3 Flickus channels so triple redundancy within the Raptor. When you pull aft on the stick, exactly like you described, Vader, when you pull aft on the stick, you are giving a request for nose translation in that direction. What flight control surface is used is transparent to you as the operator. So if you are flying, like you said, a Cessna 172 and you pull aft on the yoke, you expect the elevator itself to translate, which would then cause the nose to go up or down. Versus in the Raptor, say you watch the Raptor demonstration, you go to any air show and you watch the Raptor demo, is amazing. It is a truly it defies physics seemingly, turns into a helicopter, turns into a UFO, turns into a screaming machine. It turns into a vapor generation machine, suddenly like cotton over the shoulders. It's awesome. But if you see the nose translating across the horizon, so say you put your lift vector on the horizon, pull aft on the stick, it may not be the elevators or I'll say the stabs, just like you said, at all that move. It can actually be a combination of leading edge slats and the trailing edge flaps that cause that nose translation, which again is completely different than a normal aircraft, but the flight control laws are optimized for the max performance of this particular air vehicle. And so as you look and create that request via the side stick motion, the flight control laws will give you the optimal solution using whatever combination of flight control surfaces will give you that best motion. And so that also is it also then you have to pay very close attention to airframe buffet when you want to have good communication with the nonverbals of the jet. And so you and I understand, and other people who have flown say, if you feel smooth jet, you've got some energy on the plane. When you start to feel buffet in the jet, or if you say fly a Cessna 172 or whatnot, a perfect one of the early indications of a stall starting to form is actually the yoke or the stick starting to shake. Well, because there is no physical connection between the stick and the Raptor to those flight control surfaces, you really do need to pay attention to the airframe buffet more than what's going on necessarily at the stick, because that is going to tell you, a little bit about your energy state more than the control stick would. So so it's a digital fly-by-wire jet. It is also way smarter than I would ever be. It's more than happy to save you, or also you can, like you said, find yourself on the pain train at 600 bills, low altitude, and pulling straight back on the stick, and you'll be accelerating at 9 Gs, which is not a crowd favorite. It is something you want to avoid. But the Raptor's more than happy to give you all the power in the G that you would like.
Yeah, and I think the amazing thing about the Raptor, so the Raptor and the F-16 share similarities between a digital flight control system, but then the Raptor has 2 things that the F-16 does not. One of them is the ability to increase the pull or continue the pull, and then actually keep pulling more AOA. So angle of attack is your nose to the relative wind, and the disparity or the delta between those 2 things is your angle of attack. What that means is the F-16, you get the amount of AOA the jet allows and no more. Where the Raptor says, hey, if you want more, I'm getting slow, I'll let your nose keep going relative to the relative wind. And in addition, it has thrust vectoring, which probably helps with that. So any add-ons to that part?
Yeah, so it is in the Raptor, you can get to nearly any AOA that you desire. And so I'll point out to the audience the Raptor demo again. There's a really good example using the pedal turn. So one of the maneuvers is the pilot will take the aircraft straight up and then pull aft on the stick in order to create that stalled condition, but then you'll still see the nose translating left and right. Like it's almost like a helicopter, but it's moving left and right. That aircraft is probably at greater than 60 degrees alpha at that point, but still fully controlled through a combination of the control surfaces, the engines. It is still a fully in control aircraft. We call those maneuvers post-stall maneuvers, where you are in a stalled condition, but still controllable. And so there are a whole host of post-stall maneuvers that you may want to do in tactical situations, very short time, specific use case, because as people who understand aerodynamics know, when you're in a stalled condition, you're also losing a lot of energy. And a key axiom for tactical maneuvering is energy. You need to get energy back as soon as you possibly can. I would say energy is life. And so if you can maintain the energy, use it at specific times, which the Raptor is more than happy to bleed that energy for you, be those, high alpha post-stall maneuvers. But then it will also, make you feel much better when you put both, F-119 Pratt & Whitney engines over the hump and it's giving you 70,000 pounds out the back of thrust in AB. You can save your, it made me look like a way better pilot than I ever was, because it will get you out of the situations that your poor pilotage puts you into.
Yeah, and I think that is a similarity with the F-16 is it doesn't have thrust vectoring, it doesn't have post-stall, it has a single rudder. So if you look at F-15, F-18, F-22, F-35, all of them have two rudders in varying angles and setups. But what that allows for is to use the rudders to turn the nose across the sky when the airplane may not have the airspeed to do that via just G and using the stabs to do that. So the F-16, you can ask a lot out of it. You can get yourself behind it, but the jet, rather than just stop flying, it'll like, okay, I'm going to give you some nose track. It's going to be slow, but at least you'll get something. Where in a C model, if you ask too much, it'll just stop. You'll think you're turning, but you're really just going straight. And the wings are just kind of rocking back and forth as you kind of just, trundle along through the sky thinking you're doing BFM. And I think one other thing is, in pilot training in T6s and T38s, they tell you to fly the T. And what that means is with any sort of like F-15, you have a full flight control stick that will move. So in an F-16, if you let it, I think the displacement is like 1/4 of an inch or something like that. But it's all about force that you're applying. So you don't really have to fly the T because, again, the flight control system is kind of going to do it for you. Where in the C model, if I don't get back to a neutral stick position before I apply aileron, which means I'm not asking for nose track, I'm just asking for roll, then I'm not going to get a great roll because it's going to be a loaded roll rather than unloaded, which I assume the Raptor kind of helps out with that as well.
Yeah, you can absolutely. There are times where you would want to execute a loaded roll, so a combination of a stick and pedal, so rudder pedal, in order to command under alpha a roll. But there are also times where you want to, just like you said, go at a minimum to the center, if not push forward slightly to break that stall to get some more air over the wings or just snap it a little bit quicker. And so there are various reasons why you may want to do both. And actually, to pile on to something that you said about about continuing to pull, and you may feel like you're doing some good, but really you're just hurting yourself, is you can find yourself at slow speed conditions at our tactical floor. So call it like a 10,000 foot tactical floor for the engagement. When you're going out and doing some BFM, and you could be hanging out at like 10.5, and you're at min sustained turn rate in the Raptor, and when you can pull back at the stick, and you 100% will get your nose to move a little bit, and you'll go underneath min sustained turn rate. And when you actually look at your ground track, it's straight, because all you're doing is you're turning your nose, but you're not actually translating across the sky, which is, you and I both know, if you want to get out of the way of the impending lead headed your way, you actually have to move your jet and not just flop around. And so that that is incredibly important, is to maintain awareness on your min-sustained turn rate airspeed so that you can maintain that translation across the ground for survivability purposes.
Yeah, I flew the F-35 sim, and it was able kind of, I've never flown the Raptor or the sim, but kind of that nose track, like just kind of slice across the horizon. And, so you kind of pull back and then you just step on a rudder and it's like dial a heading. And so I was like, man, the F-16, because when you're under a lot of AOA for the F-16, the rudder doesn't really do much because the fuselage of the plane is kind of blanking out your rudder. So I was like, all right, I'm talking to these test pilots, and I was like, I have a theory. And I was like, what I'm going to do is get really slow, and I'm going to bunt and like unload all of that alpha and then stomp on the rudder. And what do you think is going to happen? And they were like, probably nothing. And I was like, I think I'm going to try it. So sure enough, I go out and I'm slow. I'm like 130 knots, which is pretty slow for an F-16. And I'm pegged on the limiter, so I'm pulling the maximum amount of AOA the jet will give me. And I unload and I stomp on the rudder, and the nose tracks like 20 degrees left, and then I just fly uncoordinated flight on the same vector I had, just the nose is not pointing. And then I let the rudder out, and the nose just kind of like wobbles back and forth and then goes back to my original heading. And I was like, well, that was anticlimactic. Like, I didn't know.
Yeah, you're like, I have got an idea that nobody's thought of before. Everybody else in the squadron, they're not ready for this.
That's right.
And then unfortunately, dude, we've all been there. We've all been
buckle up, everybody. Vader's generating tactics again.
That's right. That's right. Somebody let me take a jet out by myself, and I've come back with ideas and also a lot of sweat on my brow from being scared.
Yeah, you fools! You never even tried this before. Turns out it doesn't work. So
yeah, that's right.
Well, that's awesome. And I think one of the things is that a lot of 4th gen fighters always look to 5th gen fighters and we're like, they are clean every day. So 4th gen fighters, we just slap everything on the outside. We slap missiles, we slap bombs, we slap pods, we slap everything. And then Raptors go out there and it's like demo clean every day of its life, which is, I guess it does have gas tanks, but not usually. So I imagine that was a very slick plane that probably didn't want to slow down when she got quick.
No, she doesn't want to slow down, and and so you can get fast very quickly and stay fast for a long time. And when you pull the throttle back, it actually was interesting for people who may or may not know, the Raptor does not have a dedicated speed brake or air brake. So if you want to use what we would call the speed brake, you pull aft on that switch on the HOTAS. And then what it actually does, it just cants the control surfaces outward in order to create additional drag. And so there's no, barn door that comes up behind you or anything like that. There's no dedicated surface whose sole position or purpose in life is to be your speed brake. That's not what we have. And really because the name of the game with 5th gen and anything that aspires to be stealthy is to maintain that cleanness of your aircraft. Because everything is hanging, every missile that's hanging, every bomb that's hanging, every empty pylon that's hanging, every fastener that's not quite tight, in and is sticking out, every little thing adds up to bloom your radar cross-section, whether it be a lot or a little, but it can all add up. And you want to maintain awareness for your survivability in a 5th generation fighter, you want to maintain awareness of your radar cross-section. And so, you want to maintain a clean aircraft. So that's why in the Raptor we carry our weapons internally. So in the side of the aircraft you have the ability to carry 2 heat-seeking missiles, principally AIM-9Xs if at all possible. I started with the AIM-9 Mike, the mighty Mike, and then transitioned to the AIM-9X, and then there are a couple blocks and upgrades associated with that weapon. So 1 on each side. And then inside the main weapons bay, if we're going as God intended the Raptor to go, full air-to-air mode, then you're going to have 6 AMRAAMs in there, and then 2 heat-seeking missiles on either side of this in the side weapons bay. So 8 missiles total. If we want to go pretend to do air-to-ground well, then we will trade out 2 AMRAAMs for 1 1,000-pound bomb or 1 rack of SDBs. Which are 250-pound GPS-guided, essentially low gliders, explosive gliders. And I know you probably know way more about the SDB, so go ahead and just tell me how cute I am that I don't know what I'm talking about. But we can then, if we want to go full up air to ground, we can get 2 AIM-9s, so 2 heat seekers, 2 AMRAAMs, and then 8 SDBs. It's 2 racks of 4. That was the configuration we went in quite a bit in Operation or OIR against ISIS. We were doing some of that. I dropped some bombs on, in the Middle East during that time. But again, the aircraft, just to keep talking a little bit about the history of the aircraft, it came out of the Advanced Tactical Fighter Program. So there was that famous fly-off between the YF-22 and the YF-23. Both Lockheed Martin, Northrop Grumman competing. You can find all sorts of documentaries and history about those aircraft. Each of them, YF-22 and the YF-23, had significant strengths and weaknesses. Ultimately, the YF-22 was chosen, which turned into the Raptor. 186 of them built out of what was supposed to be over a 700, aircraft buy. Tough choices have to be made, as we think about budgets and what we're trying to achieve. And so when Secretary of Defense Gates was the SecDef in the mid to late 2000s under Bush and then Obama, we were having some major, this is just about the trades, right? So just talk a little bit less about the Raptor, a little bit about like what impacts these fighters that we care about. There were unfortunately a whole bunch of really good people suffering really bad injuries or being killed by IEDs in the Middle East. If you think about back in like 2000, the mid to late 2000s into the 20-teens, we still had a significant presence in Iraq, significant presence in Afghanistan, and the favored way to injure Americans was with IEDs. So we needed to spend some money and quickly get a new vehicle better than a Humvee out there that is survivable in that environment, and that's where the MRAP came from. And so you go, okay, I've got a problem today where guys are dying and I need to support them. And I have what I hope will never be a problem tomorrow, which is that preparation for the high intensity conflict where I need a lot of stealth fighters. I am going to cancel by over half the Raptor buy to then support MRAPs. And then they got canceled some more. So it went from over 700, I believe, to the high 300s. And then it was canceled at 186 is what we had got. And those are broken up between early lot and then like the combat coded jets. But guys more likely than not survived because we got, yesterday because we have less Raptors today, because that's the budget trade you have to make. But now there's no free lunch. Now as we pivot to high intensity conflict and prepare for what we hope will never come, conflict with a peer adversary, we now find ourselves short on one of the best assets in that conflict, the Raptor. And so that's where the F-35 will pick up, some of those requirements via quantity and its capabilities as well. So, a little bit of history lesson there.
Yeah. I like how you said the F-35 is going to pick up the Raptor slack due to quantity, not because it's... Well, I mean, so if anybody hasn't seen the F-22 Raptor demo, I mean, even on the internet, but specifically live, it is, I mean, flying an F-16 and I watched the Raptor do what it did. And I was like, nope, that's not supposed to happen. That's not how planes fly. It's amazing. It is just, I think, I mean, I'll throw it out there. It is, if not the most maneuverable, it is one of the most maneuverable fighters that has ever been built. And it's going to be hard to outperform that thing because it's clean. Its thrust to weight ratio is solid. It's got killer motors. And I mean, it's very, very good at what it does. You got to give credit where credit is due. And I think, it's tough because I bet, and sadly our acquisitions process just takes so long because it took us so long to roll out the Raptor that the Raptor was kind of like oldish technology, and same thing with the 35 now. But, they were probably making that decision with the assumption that they're like, oh, the next jet will be out in like 5 years anyway, so it's no big deal. And the reality is these things take probably a decade longer than expected, if not more. So I like you said, you have to make real time decisions and then deal with the fallout later. But yeah, that's one of those where, if you're in a fighter squadron, they're like, we need more jets. And, most fighter pilots are like, can we just build more Raptors? Like, why not just, because again, we keep, for some reason, our decision making. And again, I'm not in the meetings. I'm not mustered to make these decisions, but you're like, we have a tested airframe that is wildly capable. Like, just throw a few iPhones in it and it's probably going to have better processing than anything else we could make. So yeah, it's pretty wild.
Yeah, no, it is fascinating, the intricacies that, lead into these strategic decisions that end up impacting decades after that decision was made. And, that's where I think, iterative design and rapid fielding of future aircraft. I think maybe the former Secretary of Air Force for Acquisition, Dr. Roper, in the previous administration, he coined the term the Century Series. We're going to start this new Century Series of aircraft that harkens back to Vietnam, where we had F-100s, 104s, 106s, 105s. How did I miss that? 108. We had a whole host of aircraft that rolled out reasonably, back to back to back to back to back. And we want to spur the industrial base to get back to that. We actually have to do that. We have to put our actions, behind that. Not to get philosophical here, but anyway, I think the digital Century Series term, or the new Century Series term, I think that may be out of vogue now. But the intent of that is 100% valuable. Is 100% valuable. There's no reason why we need to wait another 10, 15, 20 years for the next, aircraft to come out. The technology exists now. The labor force exists now. The knowledge base is there. You can get more than one MDS fighter performance every decade if we wanted to, if we truly wanted to. And so, maybe we can talk about that more if we so desire, as we, about the future. But I think there are opportunities for that to actually happen.
And I think, and maybe this is a perfect segue, because honestly, I am relatively uninformed about CCAs, but we're going to get into that now. So Blue Force Technology is helping build combat collaborative aircraft, right? And then Man UnManned Teaming. Would that be something that CCAs are also working on?
Yeah, so there is it is valuable to break those two apart, although they end up coming back together. So a combat collaborative aircraft, I think there's a family of systems that's maybe a better term to use than Century Series. You want to get after unmanned vehicles that are built for purposes such as a combat collaborative aircraft. CCA would be, I would think a high performance unmanned fighter type of thing. You could have like a CTA, which is a collaborative training aircraft, something that could facilitate training. You could have a CBA, which is a collaborative bomber aircraft, maybe going with the B-21. There are kind of lanes that air vehicles could fall in that is really just under the overall umbrella of, kind of synonymously saying CCAs or unmanned aircraft. And then when you think about MUM-T, which is Man UnManned Teaming, that is the philosophy of using autonomy, automation, appropriate human-machine interfaces, data links, etc., by which a person would give a command to that vehicle or be told what the vehicle decided to do via automation or autonomy, and then work as a team. So Man UnManned Teaming, work as a team to overall accomplish a goal. It kind of goes without saying, at the end of that Man UnManned Teaming, there is an unmanned aircraft, and on the other side there is a person that could be on the ground or could be in an aircraft. So the MUM-T term is kind of divorced from the aircraft. It gets after, like, how do we make this happen, and then the CCA gets into the actual the platforms and the capabilities associated with that.
So how does CCAs, because right now we just talked about how we have a process or problem with creating new aircraft, onboarding new aircraft, rolling them out, and IOC, or initial operational
capability,
capability. There we go. I was just going to say C, but
C.
Yeah. So with Blue Force Technologies, like what are they like? What is the current problem set that they are trying to build the solution for?
Yeah, so we're gonna back this up to like 2017. So a little quick background: Blue Force Technologies, based out of Raleigh, North Carolina, a business that's 12 years old, growing year over year, and principally working in carbon composites for aerospace and space purposes. So we have traditional prime aerospace customers, and we also have been doing composite development work for space customers as well. And in and around that time, the 2017 timeframe, decided, hey, it's awesome doing work for others, but let's start making our own stuff to put our own sticker on. I think there's a need here for a high performance unmanned vehicle. Let's start shopping that idea around. And so the company made the pivot, which is, as companies do, in a direction. Actually wrote an open topic SBIR phase 1. So got a $50,000 3-month period performance, took that time in order to go door knock every single day at Air Combat Command. And that's actually when I ran into them, was when they were getting feedback from operators, which is exactly what you're supposed to do under SBIR phase 1. Anybody who's listening wants to talk about the SBIR process, hit me up. We can talk about that later. But got a SBIR phase 1, turn that into a SBIR phase 2, $1.75 million over a year period performance in order to develop to a preliminary design review the air vehicle. And it got turned into the aircraft we now are calling Fury, but it is a high performance unmanned RCS managed fighter. And it has had for the first couple of years here a use case of adversary air. And so I would commend the recent podcast that you and I were just on, where we talk about adversary air. We can rehash some of that for the listeners, but because there's so much we don't know about how to work together with a high-performance unmanned low-observable fighter, because nobody's ever done it before. We should probably start in the highly regulated environment of training. That has been the thesis. But ultimately, I also don't want the air vehicle to be binned, unfortunately, unnecessarily binned with only that mission set. Because as you and I can understand, in those who think about this, there are a whole handful of missions you can do with a high performance, low observable unmanned fighter, like offensive counter air, like defensive counter air, like SEED, there's a whole host of things that the air vehicle could do. When it is not in combat, it is going to be reasonably good at adversary air. When it is needed to go to combat, which we hopefully will be never, then it will be part of the kill web in order to sense and act against an adversary. And so that's what Fury is doing. So to paint a mental picture of what it looks like, it's just a little bit smaller than T-38, single engine, 28 feet long, 17 foot wingspan. It goes up to 0.95 Mach, 50,000 foot. We've got a simulator model flying. It's awesome. It's a blast to fly. It'll be controlled from a ground control station like a UAS. And so we're really excited about it. We've been talking a lot to Air Combat Command in the bros, right? We go, hey guys, you need better quality and quantity of adversary air. Your sparring partner, your practice squad that you go against every day is probably they're great people they're great Americans doing great American things to try and sharpen the sword, but we don't have the quality and quantity. How about we give you a reasonably priced, easily produced with commercial components, high performance, low observable unmanned fighter to train against? Okay, everybody understands that naturally. We need a better sparring partner in both quality and quantity. And then let's take that forward when the balloon goes up too. And so it really is a Swiss Army knife of an airplane when it comes to any mission set that you would want to use a fighter for. That's where our aircraft could work too.
Well, and one of the things kind of gives some more background, when you're building an airplane, there is a lot of weight and space and effort spent on keeping a human alive in that airplane, letting them get out of that airplane, and then in addition, like interfacing with the airplane. So now we're talking, none of those things are required. We don't need all the electrical that the pilot has to interface with. We don't have to steal generator power and output to run the environmental control system and all that stuff, that's all gone. Now it's just like, I just need a plane to do the job, and then I'll work with it from a distance. And how does it work with a higher performance platform with like any sort of latency and in like transfer and all that kind of stuff? Because I don't know, but my understanding is there is some latency, obviously, when you're like around the world.
Yeah, 100%. And so I'll talk about the design choice freedom, and then we'll talk about the latency. So it's similar to like when you remove the internal combustion engine out of a car and you go with like a skateboard electric, vehicle, then the whole world is open up to automotive designers to do different things with the front of that vehicle for drag reduction, storage, crazy lights or whatever the heck they want to do. Now, when you don't have, a big hunk of lead up there, steel, then you can do anything you want to make that vehicle different or optimized for what you want to do. When you remove an operator from inside the aircraft, you can make different design choices because you don't have to make a tub for a dude or dudette to sit in. You don't have to, make those displays, and you don't have to keep that person hot or cold because, gosh darn it, I'm picky when I fly. And so you don't have to do any of that. And so you can make some design choices and move things around in different ways and offer the opportunity for aeronautical engineers to be creative to optimize the air vehicle. Now, getting into for the mission sets that are in question, I should close that thought out with that. So when it comes to the data links, there are two principal ways you can control a UAS. There's the beyond line of sight, which is BLOS, principally through SATCOM. So you think about like an MQ-9, where guys are sitting at Creech Air Force Base and they're controlling things in Afghanistan. They're using satellite relays in order to bounce that communication. And there is some latency, but not enough to impact the mission. We can still successfully get the mission done. If you go with a line of sight radio, one that the transmitter on the ground or transmitter on a aircraft or wherever the transmitter is, it goes straight to the receiver. You actually minimize the latency, as much as the speed of light. And so that is so a combination of those are how you would end up controlling a UAS. And again, depending on the mission set, there's value in flying around the home drone with using line of sight. Why do I need to use latency of SATCOM and the expense of SATCOM when I can just use line of sight when I'm just flying around the flagpole at home? But then if we want to go, kick in the door somewhere, we probably will be using a combination of both, or so there are some trades. And again, the best option has to be bumped up against what the mission set you're trying to do. So as you and I, let's work from the target backward. What are we actually trying to accomplish? Then let's build it back. Let's build the air vehicle around whatever that is trying to accomplish.
One of the things that I've talked with a couple companies previously, like a SBIR 2. A SBIR 2, the end state, a successful SBIR 2 ends in a min viable product. It does not end in it doesn't end in a Raptor. Like that is not what a SBIR 2 will produce you. And the problem is you get this I don't know if this is exactly the term, but like objective creep, or, like you every time you're like, well, could it do this or could it do that? And now all of a sudden you're asking something to do a lot more than it was initially supposed to, or then you're like, well, I wanted this to be cheap and now it's super expensive. And it's like, well, because you asked for all the expensive stuff. Like, I don't know what to tell you. Like, you shouldn't have wanted Napa leather, like there's at some point, like we have to, like you said, like what is our objective and how do we best achieve it? Rather than just trying to put all the bells and whistles on something that may or may not need them all.
Right. And I would just say too, we're really living in a really amazing confluence of advanced manufacturing techniques, high power compute in small form factors, and automation transitioning to true autonomy, where iterative design is the way to go. Let's think about the F-16, for example. The F-16 was designed to be a daytime VFR, but put fear in the hearts of our enemies because it is going to crush you in the air-to-air. And then suddenly it's flying with, lightning lantern pods, hanging bombs and rockets off the side. And now it's like, it turns into a multi-role something, which has value, but you now, as you start putting bumps and humps and other things, all of the aircraft, it becomes less optimized for what it was intended to do. And when we think about future UAS designs, there are those, and I'd be happy to be corrected. I'd be happy to get feedback from anybody, but I perceive, based on, again, advanced manufacturing and small compute and open architectures that can be extended to other air vehicles, there is no reason why a CCA should be multi-role. There's no reason. This is SCAR's theory. We're planting the flag. But again, I'm open for debrief, to be told that I'm dumb and I'll learn. I mean, I'd love to learn. But here's what I think should happen. The XQ-58. The XQ-58 built by Kratos. It's a rocket launched, moderately fighter size, T-38-ish, single engine, inlet on top aircraft. Been flying since 2018 under a lab project. Did work with Skyborg and whatnot. The XQ-58 has a role as an expeditionary air vehicle, forward, runway independent, launch it, enter into the sensing grid, maybe drop some weapons, maybe not, but really sense and provide information to the grid, and then come back. It has a role. When you don't need runway independence, don't use it. But when you need it, use it. But because autonomy doesn't have a muscle that atrophies, keep it in the crate until you need it. But you have it ready. Let's talk about the MQ-9 or the MQ-20. They're great aircraft for what they're designed to be used for. Don't bolt on additional stuff to make them less optimized for what they're used for. Use them when you need them, and don't when you don't. Not everybody has to have a trophy here. If the war doesn't require you, stay home. Red Flag should learn that lesson. So then you go, like the Ghost Bat from Boeing. Recently flown down in Australia, pretty awesome airplane built by Boeing Australia. It has a role. When you don't need it, don't use it. Keep it on the ground in the hangar. But when the mission set requires its optimized performance, use it. Same thing with Fury. Again, the whole point here is that we need to have a family of capabilities of aircraft that have architectures that are the same, using autonomy command messages that are universal, so that when you take off in your C model and you hand it off to a P8, you're speaking the same language. And it is for a purpose, and when you don't have that purpose, you don't use that thing. I just think about a multi-tool. A multi-tool has a fingernail file and pliers and a Phillips screwdriver and all this sort of, and it becomes bloated, and it is not your best pliers. It's not your best fingernail file. It's not your best Phillips head screwdriver, but it's okay at all of those things. Yeah. And I would say that when it comes to the future iterations of unmanned vehicles, we should not make air vehicles that are okay at all of the things. We should make air vehicles that are amazing at the few things that they're designed for and crap at the rest. And that is okay. And that's okay. It has to be okay.
And I think that's the whole point of them, is like, let's make them relatively cheap, modular in nature, and then have very specific attributes to be able to do very specific things. Because I think, and this is not a spear to the Raptor community, because I think, especially at the time, there was a very useful role for the Raptor doing like deep strikes or, like SAM takedowns. But it's like, hey, we have the most advanced like maneuverable fighter on the planet dropping SDB. And it's like, we have a lot of jets that can drop SDB. Now, granted, dropping SDB on some heinous new SAM, I'll let the Raptor do that. But it is like stuff like that. So I agree. Like, let's have, coming from an F-16 guy that's like the whole pitch. It's like, it's become the jack of all trades, master of none. And you go to a C model squadron and they're like, yeah, well, you did F-16 TI, you didn't do a true TI. And they haven't really, they haven't actually said that, but I kind of like, hey, I haven't done C model TI, I just did TI where you had like 3 or 4 other mission sets going, so you never really got into the weeds. So I agree. Cause I think maybe it's easier to sell, or people like to be able to say, oh, no, this doesn't just, this doesn't this slice, this dices and it does everything else, because it's easier to get people to write checks for that stuff. So, but as a tactician on the tactical side of things, like I want something to be eye-watering at its job, and then build something else to be eye-watering at its job, like you said. And so I couldn't agree more. So if you got a problem with SCAR, then you got a problem with me too.
There we go. Yeah, I just think it's when because of we live in a really special time when it comes to making things that have reasonable performance at reasonable prices. And it will not, all of those things will not be the platinum, gold plated solution. You're going to leave some performance on the table, but again, that has to be okay, because, and then what you also do when you create a family of systems with optimized capabilities with, again, specific mission sets, you continue to keep the industrial base active. Because if you give a performer a multi-role fighter for multi-decade, then it is only those people who play. Versus if you democratize the production of these CCAs across a family of providers to create that family of systems, all you got to do is just do that. And then you've satisfied what, at the OSD level, Heidi Shu and others have said. They decry, oh my gosh, we need to keep the industrial base active. What are we going to do to keep the industrial base active? Here's an example. Democratize a family of systems of unmanned aircraft, whether it be fighter performance, bomber performance, ISR performance. I don't care. You have to democratize out to a family of systems.
So how is kind of focusing on the Blue Force side of this? So obviously you said they were not surfaces, but what were they building initially?
Yeah, so Blue Force was building, or has its core business is building composite aerostructure for other customers, ranging from, like I said, eVTOL, space, airspace, aerospace, a whole host of customers, which is awesome. Yeah.
So how is that now, and kind of help expand on this, like engines, software, all the other stuff beyond the composites, like how are they building that? Are they working with other companies, or how does that work?
Yeah, so that also like dovetails into, we want to use the people in the companies that are experts at what they do, and then we do what we are expert at. So we are expert. We can integrate aircraft together, build the structure, build the support, the spars, the skins, everything associated with the aircraft, landing gear. We put all that together. We are not an engine manufacturer. I don't want to become an engine manufacturer. There are amazing engine manufacturers out there, so I'm going to buy their engines. I'm not a mission computer manufacturer. I don't want to build chips. I don't want to do that, but I'm going to use the people who have well vetted with millions of hours mission computers and flight computers. I'll buy their stuff, which is probably already FAA certified. I don't have to go through that. They've already done it. I want to integrate that quickly on my aircraft. So then the design of the hydraulics and electrics we do all, we're working with that with some partners. The fuel system, we're tackling all that too. But when it comes to all those piece parts, again, you have a supply chain and you have an industrial base who have expertise in those areas. We bring that together with our design in our aircraft, which we'll build. We'll integrate the vehicle, and then we'll get to ground and then flight test and then fielding.
Which I think, I mean, obviously you guys have thought through this pretty well, but yeah, I think that's a good approach, because why try like, hey, let's try our hand at building jet engines, and then it's going to be this like massive problem, rather than just being like, hey, this works. Because I think it's always about like this exquisite technology, and it always seems to have some new like capability, or this new, it's like, no, we can't use the old engine. We have to fabricate a brand new engine that somehow is different than every other jet engine. You're like, okay, I mean, I guess like that, you tell me, but.
Yeah, that's that. You bring up a good point of like the approach where, in an example like you just described, you could have an engine manufacturer come to us and go, what performance do you want? And actually what we do is we go to the engine manufacturer, go, what do you have? We'll wrap that in carbon. We'll build an airplane around that, because leading back into, a comment I said earlier and I still live by, is like, speed is life. And if we want to have something out flying ASAPly, then we have to go with what's already out there. If we require more developmental programs to support this aircraft getting off the ground, everything will just continue to slip on schedule and increase in cost. Or I can see what's already on a hot production line rolling off right now, squeeze every ounce of performance I can and go and let good be good enough. Because guess what? We're going to iterate the next design next year. We'll iterate the next design after that. And so it really has changed because let's talk about the Raptor and the F-35. The Raptor Pratt & Whitney F-119 engine, amazing engine. The F-35 brand spanking new engine, not used anywhere else. The Raptor's engine, not used anywhere else. It just points exactly to what you're saying. These are bespoke power plants that are amazing. They have amazing engineering, amazing people build them. It's all great, but it was a brand new developmental program that probably did cost billions of dollars, or we could have just used the 229.
Yeah.
Maybe.
Well, and,
I don't know. Or
yeah. Well, and it creates a ton of thrusties. I mean, like the 35 creates more thrust than the Raptor, which is kind of insane to think about. But it's like, Raptor motor's probably pretty darn good, So
yeah. Well, now we have to re-engine the 35. Seemingly.
Well, and that's the tough part. You have like these. There's no perfect solution. The F-16, the U.S. F-16 has 4 variants in motors that it's currently flying with. And we're like, why so many motors? But then it's like, well, the F-35 only has 1, and people are pissed off about that. And you're like, touche. Like, I don't know.
Yeah.
So the one thing kind of to give people the big picture. So obviously we've kind of explained what CCAs are. And so 9 level, the future that you envision CCAs doing, like what does that fight look like? What does that training look like? Like how are we training with CCAs? How are we employing CCAs in combat?
Yeah, so let's actually reestablish why do we even need CCAs in the first place. So the reason why we need CCAs is because we perceive an extreme level of risk in that hopefully never to happen high in conflict. Like it is extremely challenging in a kinetic and non-kinetic arena, in a very expeditionary, not logistics challenged arena. If I'm thinking about like the Indo-Pacific. And so it's an away game with not a lot of runways and not a lot of availability to get your logistics moving. And when you get into the theater and you fence in, it is freaking high threat, dude. You're getting jammed, you're getting shot with extremely long range weapons. And we are challenged in that arena. They would be too, but we don't have enough mass. And so how do you darken the skies with more iron that's capable while you get after reasonably priced, unmanned fighters, hopefully, I would think. And so in the future, I envision a family of systems. There is the RQ-170 is a great airplane for what it's designed for. I envision the RQ-170 or another, call it flying Dorito. Those things are in vogue with the B-21. There was the B-21 family of systems operational imperative from the Secretary of the Air Force that was out there. I imagine there could be an unmanned bomber that's been said publicly as a desire. I imagine we will continue to have long loiter ISR, maybe for comms relay purposes, because more likely not going to be a counterterrorism fight. So if we need something that's going to sit up there for 24 hours, it better have the ability to talk and relay information. I envision a no kidding high performance, low observable unmanned fighter that's going to maybe not necessarily be on the wing like you're checking, as the line abreast at 3 miles stacked high, waiting for the delayed 90. I don't think that's going to happen, but it'll be out there ready to do some fighter integration, or provide that outboard sensing and also be survivable when it's shot, execute that last ditch maneuver to create that miss distance away from that missile. You have to have fighter performance to do that. And because that's the arena that you and I and our pink bodies will be in if we go. So it better be there to help me. And it better have the performance to survive in the arena that I am in and it should be helping me in. And so I envision the whole gamut with a number of vehicles in each of those bins. So combat collaboratives would be unmanned fighters, combat ISR, which would be like kind of long loiter, bomber. I envision more than one vehicle in each of those bins, I would hope, because then that keeps competition going. It gives multiple different options. But the critical part here isn't really the platform. I would just say this is going to be strange when you hear a platformer say the unimportant part is the platform. But we cannot have every single one of these things have different data links. because then it's not going to be able to communicate with anybody. It can't, internal to the aircraft, the messages that you send, like turn 90 right, it better be in the same format, the same language, no matter what aircraft is sending it. We don't have common languages or common OFPs in any of our fighters or weapon systems right now. We don't even own the OFPs. By we, I mean the government. Sorry. Yeah. By like America. You know, the American taxpayer doesn't own the OFP in the F-35. And so but we better have it speak the same language. And so really I would just say the air vehicle itself, like the carbon wrapper or aluminum wrapper or whatever the material is, really is the unimportant part. That's what the advanced manufacturing enables. Is really just an exquisite dust cover of the mission systems that are inside of it, because that's where the money is made. It's actually the mission systems. So that's what our philosophy is. We are we want to make the airframe unimportant. How do you do that? And rapidly iterate, make it inexpensive, and move out.
Yeah, well, that was one of the things I saw Elon Musk speak, and what he was talking about, because somebody asked him the question about the like Tesla, how all of their stuff is like open source, or I don't know, I'm not a scientist, but he was like, well, if you're innovating so fast that it doesn't matter, like if people are stealing your data, they've got 6-month-old at best data, like who cares, you know? So I think that's one of the things, like if we can move fast enough, then that iterative process, like it's only going to get better, rather than like, hey, we test an airframe, the airframe's good, but we already bought the internal guts of the avionics a decade ago when we were building the plane. So we have to keep those decade-old avionics in it. And you're like, no, like years, and we're turning stuff out and we're putting it out on the, to fight. And now like keep up with that. Like that is a serious problem set. And it cracks me up. OFP, the operating system. So think like iOS for iPhone or anything, they're all different. And then every plane you hop into is going to have a different like pilot vehicle interface, or PVI. So it's like, well, this button does this and that button does that. And well, the C model community like kind of took over the Raptor initially. So then the Raptor was like all the same buttons as the C model, even though it's side stick, and the 35 is like the F-16. You're like, holy cow, guys, can't there be like a human factors like study and just like, this is the best way for a human to interface with an aircraft? No way, no money in it.
Vader for president, preach it. Keep it up. I like it, dude. Yeah, I like it a lot.
Well, it's self, it's helping me, because I'm like, man, this is like, it could not be more different on how I interface with the C model from the F-16. So I'm like, well, at least I don't have bad habits. I just have no habits.
You just have no, yeah, that's right.
Yeah. So, well, I'll let you get going in a second. So kind of parting shots on CCAs in training. Where do you see their biggest use? Like, are these LFEs, is this daily training? Like, where are they going to be best used?
Yeah, that's a great question. I think, if/when we can take a high performance unmanned fighter like Fury and move it into the training environment, it is going to be really good in an LFE. It'll be really good in day-to-day training, because, as you and I understand, for those who don't, when you walk into a fighter squadron, it probably is executing a training plan. There's a well thought out schedule of what you're going to be executing that week for that month, for that quarter, to overall satisfy your training requirements for the year. And as you go into beyond visual range engagements, so TI, maybe some ACM, depending on whether you're 5th gen or 4th gen ACM, we'll talk about 5th gen ACM, which is principally BVR, turned to visual range, and then tactical intercepts, and then OCA, so offensive counter, and the DCA, defensive counter mission sets, you get the quality and the quantity with an unmanned fighter replicating that J-20 on the other side. And then it could also be your striker, could fulfill that striker role or whatnot, because we need greater numbers, we need to be outnumbered, and we need to be challenged in the RF spectrum with an adversary that replicates the tactics and replicates the trons as far as the electromagnetic spectrum coming off. I don't think that it is that CCAs are going to be in the next 5 to 10 years suddenly doing unmanned BFM all over the place. I don't think that I think there's really amazing stuff going on with the performers on the DARPA ACE program. I know those guys, amazing dudes doing amazing work. I think that is the BFM mission set from a perception, decision, execution standpoint. the perception is extremely challenging because your machine learning agent has to have an understanding of where the adversary is to then make a decision and then command the aircraft to execute it. You and I just turn our heads. We just look. And we just go, tally, at my 6, because of course I'm terrible, so he's always at my 6. but that machine learning agent may have to rely solely on the onboard sensors. And if it's outside the field of regard of your radar or other sensor, it doesn't know where that aircraft is. So how is it going to make that decision? I think these are silly, easily solved arguments, but they have got to be solved. And so I think BVR is the first and best place to earn that trust. This is maybe the most important thing that is under discussed about DARPA ACE. It is also under discussed in the CCA world. We often talk like, hey, what is this next unmanned fighter going to be? Hey, what's this autonomy going to be? And as you and I understand, if we're going to put a new widget in the hands of the bros, we have to build trust in it first before we use it appropriately. And so that's why you go through the testing process. That's why you iterate and develop and get that feedback. Because if we throw something over the fence and go, here you go, fellas, figure it out, and then it unfortunately maybe hits you or hits the ground or doesn't provide meaningful training, then nobody's ever going to want to use it again. It's going to start from a trust deficit. But if we do this right, and it doesn't hit you, it doesn't hit the ground, and it provides meaningful training for you on a random Tuesday sortie, then we're going to slowly start to build that trust. I'll just point back to something new that was put on the Viper, as you know way better than I do, is auto GCAS. Auto GCAS is like the lowest level of automation. Like, I feel like I'm going to hit the ground, save myself. Yeah. And people still didn't trust it until it had to prove itself. It had to prove itself at home. It had to prove itself in some interesting situations. So guys are alive because that was built, but when it was initially fielded, it didn't have trust. And so I think CCAs have to be iteratively fielded. That doesn't mean slow. Iterative should not be confused with slow, but deliberately put out in meaningful scenarios such as training in order for us to get after it. And actually, if you listen to the Commander of Air Combat Command, General Kelly, he says the exact same thing. So we need to get out to the bros at Nellis and have them kick it into the dirt and tell us where it's good and where it's bad, and we'll just iterate from there. That's exactly right. It's exactly right.
Yeah, and I couldn't agree more, because I think, with humans, we just have a inherent and innate belief that hey, the other human's going to do their responsibility, and if they make a mistake, it's a mistake, and we'll move on. But with a computer, it's like, nope, don't trust it, So if those things happen initially, I think that would be very bad for the bro level desire for it. Where if you do that iterative process and you bring it on board smartly, not trying to say hey, okay, you can BFM it now, and then it's some trash BFM or it's a trash ACM adversary, and you're like, this is a waste of my time. I'm not using this. Right. But if you use it just to plus up long range numbers, because that's really what Red Air is. You're like, hey, 10 of my friends and I are going to go out and do air to air. 4 of us are going to be good guys. The other 6 are going to be bad guys. And the other 6 are just there to give you training. If we can plus those numbers up, and it's 1, 2 guys on the other side providing you training, but there's 6 pieces of iron out there to shoot at. Yeah, I agree. That's going to be sweet. So, Scar, thank you for joining me on the show. Can you tell everybody your way to contact you if they're trying to reach out, work with Blue Force?
Yeah, absolutely. So if you want to have some more chats about what we're talking about, I would love for people to give me some feedback. You can find me on LinkedIn, Andrew Van Timmeren. You can also find me, via the Blue Force website, reach out via there, and I would love to chat. Vader, dude, this has been awesome. I really appreciate the time and the opportunity. Thank you.
Yeah, thank you. I appreciate you also taking the time. And everybody, remember, we talked about give us 5 stars if you're down, tell your friends, and then send us any questions or any topics you want to hear about from the Kodiak Shack. We're always listening. info@kodiakshack.com, and then our website kodiakshack.com is where we're going to be, where you can go check all that stuff out. So Scar, thanks again. I appreciate it.
Thanks, buddy.